everyone, welcome back to my YouTube channel, and today we are going to learn about Docker in IntelliJ. Without further ado, let's have a look on our agenda for today. So first of all, we need to install the plugin. IntelliJ actually provides Docker support using the Docker plugin, and the plugin is bundled and enabled by default in IntelliJ Idea Ultimate Edition. If you are using IntelliJ Community Edition or Edu Edition, we will need to install the Docker plugin. But no worries, I'm gonna show you in the video how to do that. We will go through the initial setup, for example Docker registry setup. The most important part is show services. So basically I'm gonna show you how to use the services window along with terminal window, because everything actually happens in services window about Docker in IntelliJ. So in this video I'm gonna show you two hands-on examples. So one for Postgres database, dockerizing Postgres database, and the other one dockerizing a Java Spring Boot web application. So apart from that, you will be learning how to use containers, how to use images, how to use mount point, how to use the port binding, show processes, exec, terminal, all those cool stuffs that actually comes with Docker plugin in IntelliJ. So after watching the full video, you will be super confident using Docker in IntelliJ, and if you are a beginner, I think you will also get along pretty well. So let's start doing the setup. So first of all, you need to open up IntelliJ Idea and then click on New Project. And once you click on New Project, this window will pop up. Depending on the version of IntelliJ, you would see a couple of options. For example, extra options like Java Enterprise, Spring Initializer. Those stuffs actually comes with Ultimate. So if you are using Community, you would not be seeing that unless you do some plugins installation or something. So we're gonna create this project, and in this project we are gonna use Spring Boot 2.5.3 version. Excellent. We have created our project, and now I'm gonna show you how to install the Docker plugin so that you get the integration in IntelliJ, Docker integration in IntelliJ. So what you have to do, if you're on Windows, click on Settings. If you are on Mac, you just need to click on Preferences, and after that you click on Plugins and click on Marketplace and type in Docker. If you have not installed, Docker should pop up, and click on Install. Since I'm on Ultimate Edition, so mine is already installed. So once you have installed it, just then go to Build, Execution and Deployment and click on Docker. That will open up Docker registry. So in here you can also add multiple registries. For example, if you have registry in Gitlab, Azure or Google Cloud, anywhere, you could actually configure them here. In this video I'm gonna configure my Docker Hub account. If you do not see connection successful, it means that you probably typed in a wrong password, or probably your username is incorrect. So make sure that you have typed it correctly. If you do so, then connection should go successful. So once you have done that, click on View and Tool Windows, and from there Services, and this window is gonna pop up. And here we're gonna now connect to the Docker node. It's because my Docker daemon is running. In your case, if it is not running, start the Docker daemon. Otherwise you will see connection error. So once you have connected successfully, then you're gonna see all the images, under images, all the containers running, and stub containers, under containers, networks and volumes. If you click on Edit Configuration, this window will pop up, and here you can see Docker for Mac. If you are on Windows, it will show Docker on Windows. It does automatically detect it for yourself. You do not have to do anything. I will delete the connection and make the connection again so that you see it from the scratch. So once you do so, click on Add Service, and then this window will pop up, and you see that the connection was successful. In this case, if the Docker daemon is not running, then you're gonna see error. Remember that you need to start the Docker daemon. In the Services tool window, you can pull and push images, create and run containers, manage Docker containers, manage images. You can fetch a lot of metadata. So With other tool windows, you can instead type in the name of an image or container to highlight the matching items. So throughout the video, we'll be using each and every options that I right now click through. So first of all, let's take the image pool option. So when you click on, it will take you to this that you see on the window. So if you're on Windows, you can get the auto completion, also in Mac as well. So if you're on Windows, you can press Ctrl space. So when I type R, a lot of options are actually suggested. So we are going to pull Nginx image from Docker Hub. So to start pulling images, you need to press Command Enter or Control Enter if you're on Windows. So we have successfully pulled images from Docker Hub. So if you right click, you can see create container, push image. So you can push image to a particular container registry. So in the properties, you can see image ID, tags created, metadata information. And if we go to the inspection, then you can see a lot of information about that particular image in terms of working directory, repo tags, a lot more information. So now I'm going to show you in the terminal by running docker ps-a command. So this will list all the running and stopped containers. So I have got 3 stopped containers. So under container section, you can see all those 3 containers. We can attach our running container to a particular network. So first of all, we have bridge network. So what it means is that a bridge network uses a software bridge which allows containers connected to the same bridge network to communicate, while providing isolation from containers which are not connected to that bridge network. The host network is not isolated from Docker host, which means that if we run a container which binds to a port, and you can access that particular port from the host IP address. If we are using none for a particular container, it means that we are disabling all networking. So we see list of volumes. So you can actually list them also running docker volume ls command, and you can also delete them if you want to. From the UI, you get pretty good overview of what is going on the container level, image level, network level, and volume level. So if you had to run docker CLI command, you needed to run a lot of commands actually to gather those informations that you see in the UI. Now in this section, I'm going to show you how you could possibly work with a database. So in our case, we are gonna create a Docker file for Postgres database. So the reason I'm showing you the Docker file is just to show you how you could work with different version of Postgres. So I'm gonna use arg, means argument, and pg tag equal latest. So we are by default setting latest Docker image from Postgres : pg tag. So during the build time, we can pass the build argument. For example, Docker version 10, 9, 11, 12, or whatever it is we want to work with. So as you can see on line number 2, click on the getter sign and new configuration. So in this window, if you notice carefully, there are 2 sections. One is for build, another one is for run. So build means in this part we will take care of building the image, and in the run part we will be taking care of running the container configurations. So during the build, we want to pass in the pg tag equal 11. So we are telling Docker that do not pull latest version of Docker image of Postgres, rather you give me the Postgres 11 version Docker image. So you can bind port. So for the host part, I'm choosing port number 15,000, and for the container part, we are gonna go with default 5432 Postgres port. And in the env var, you can set up like username, password, and databases. So here I'm going to show you how you could do that. So you type in Postgres_db, and I'm giving it a name testdb. Postgres user, we pass in admin as a user. Postgres password, we pass test123, just some dummy passwords. Alright, we are good to go. So now we're gonna run. So once we run, it should, first of all, it should pull the image Once image pooling is done successfully, then you should fire up a Postgres container with the version of Postgres 11. So when a container runs, you can get a lot of information. You can actually, during the runtime, you can access within the container its file systems. Here you can see on the screen. And you can also run commands to fetch information from the container. So let's run this command to connect to Postgres database. So we pass in PSQL -u, u is the username, then the password. Do not put a space, then it's not going to work. And you put the port number and the database name. Bam, we got connected, right? I'm listing the database and the user, for example, in this case. And once you fire up a container, you can still go back to edit configuration, and you can modify them during the runtime as well. So when I was configuring, I did not actually add a volume mount point, but I have done it afterward, right? So this is what I just wanted to show you. So in the build log, you will be seeing log associated with Docker build image. So under the log menu, you can find actual application logs. So in our case, Postgres running as an application, so we can find Postgres logs here. So now we are going to connect to our Postgres database using PgAdmin 4 tool. So what we have to do, you need to type in the database name and then the host, in our case localhost, and the port. Port is very important because we exposed port 15,000, and then the username and then the password. Once you do so and click save, it should open up a connection. So here you can see our database testdb, and if you click on tables, we have distributors because that's the empty table we have created, but there is no data in it. Just keep in mind as a side note, when you try to connect to your database using PgAdmin or using a similar tool, make sure that your Postgres container is running, and most importantly, the correct port number that you have exposed. So if you right click and edit configuration, you can double check your configuration, click on modify and see if you needed to add more. So we click on run options, and I'm gonna tweak my configuration a bit more. So -m means memory, so I allocate 500 megabytes for this container when it runs, and kernel memory should not use more than 50 megabytes. You can add a lot more information here. I'm just showing you some of the possibilities that you could add when you run a container. So during the build phase, you could also do that. Let's assume you wanted to change the port number. Instead of 15,000, you could put 7,000. You could do that as well. So in the run options, I'm going to pass one more option called restart always. So when container fails, it will try to restart. So you can right click and you can pause the container. You can start the container. You can stop the container. So you could do a lot of the things from the UI. So now I'm going to delete image and container, and I'm gonna pull Postgres image again. So this is something we did like Nginx. So you type in Postgres, and if you do not pass in a tag, then it's gonna always pull the latest images from Docker Hub. Excellent. Now we are gonna move on to Spring Boot web application. So in this application, this is a very simple application that does some hello world stuff. But the idea here is to show you how you could bind port, how you could use the mount point, exec, terminal, and all those stuff that you need in your development. I'm gonna share this code later on my GitHub repository, so no worries, I will add the link in the video description. So if you're interested, you can pull and play with that, and the container image will be also available on my Docker Hub public repository, so you can pull and play with that as well. So click on add new, and then you choose Spring Boot, and if you want to change the name, you could, but the one is important is the main class, right? So you can browse to the main class and choose the correct one and click OK. And now we're gonna run the application. So many ways actually you could run using the UI, you can run using the CLI, or you can run using Maven, Gradle. A lot of options are available. So whatever you are comfortable with, you can just go ahead with that one. So as it seems, we are able to run the application. Just stop it, and you can run from the terminal as well. So I'm going to show you how you could do it also from terminal. So we're going to run very simple Java command instead of writing or instead of running Spring command. So I'm going to use Maven. So Maven clean package. So I'm going to build an artifact out of this application. So by default, the artifact is going to be stored under target directory. So you can find the jar file there. Because I did not make the var, rather I put the jar file. So you could also right click on that jar file and build it from there, or you can run it from the CLI command. As you can see, I do it on my screen. So now we are about to dockerize our application. To do that, we need to create a Docker file, and from JDK 16, so we are gonna use OpenJDK version 16, copy everything from our current directory / opt directory within the container, and once I'm in the container, my working directory is going to be /opt, right? So we're gonna use entry point. So entry point is going to be Java, then we pass -jar option and path to our jar file. That's it. So our Docker file is pretty much ready. Also forgot to mention in line number 1, OpenJDK. So if you're on Mac, you can actually press command. And see the magic. So on line number 1, we have got the gutter sign, right? Gutter icon. If you click there, run on Docker and build image on Docker and new configuration, I will walk you through and explain all of those options in this video. So let us start with the second option. So second option is about building the Docker image. Once you click on that, it's gonna build the Docker image, but it's not gonna run the container, right? Because it's not supposed to run the container. So everything that you do related to Docker is actually translated to Docker CLI command, right? So this command I'm going to show you in the terminal is Docker build command, right? So Docker build command, we can build the Docker image using CLI. So instead here with the second option, we do not have to do that, right? It does through the UI. So it cuts off all those manual work that we were doing before. So I have got some dangling images, so I'm going to clean them up. So you could also do it from the UI as well. I just wanted to show you this is the similar thing we were doing before from the CLI. So now let's play with the first option. As we talked about, we will go through all of them. So first option is run Docker file. So what it does behind the hood is that it will build the Docker image and it will run a container out of that image. And this container, you do not have not configured anything, right? Because it doesn't let you. So what it will do, it will put a random unique container name, as you can see, and then the image name is going to be the OpenJDK. So here, if you go through the different options, in this case, you can see this container running container is attached to the bridge network, right? And in the log option, you can see application logs, and here you can see the service actually is not exposed to the host machine. The reason is that it did not actually bind the port to the host machine, rather it internally exposed the port 8080. So this is why you couldn't access the service anymore. So we needed to bind the port, container port 8080, and then we are able to access our services. So this is the disadvantage of this one, because it runs everything and you have no control of, right, during the run. But after it runs, you can customize, you can go through the settings and you can customize according to your needs. It didn't have a data volume mount points, but during the container run, you can see the file system as well. You can access the file systems. Just a quick tip in between. So when we put the host, we could put our local host like 127.0.0.1, or we could put, so if we put that, then you're gonna see IP version 4 and 6. If you do not put anything there, then it's gonna be IP version 4, so which is equivalent to 0.0.0.0. So let's remove the Docker container and Docker image, and we're gonna start fresh with the third option that we talked about just a while ago. So click on gather icon and choose to new run configuration. So in the new run configuration, as we have seen before in the Postgres section, we're gonna use enable build kit. So build kit actually will summarize the build time, basically for each layer how much time it has taken during the Docker build of this particular image. You can name it, the name Docker file, it can be anything. From modify options, you can also choose command preview. So if you are interested what equivalent Docker CLI command it would be, you can just see them as well. So as you update your configuration, the command preview will also update Docker CLI command as well. You can also expose to multiple ports if that is required. So you are open to do that. Later on, you can also delete and update the port number as well. So once you do that, you should be able to see the container running on new port. So in the command, we are gonna run this simple command Java version, and we're gonna also choose attach to container. We can also add environment variables. So you can add here env variable. If you require, you can update them later. So this environmental variable is going to be injected during the runtime, right? So when you run the container, fire up the container, these variables are going to be injected. So in the run options, we are telling Docker container use only one CPU. Hostname is going to be web app. If you do not put a hostname, then container ID is going to be hostname, right? And we pass in also remove --rm command. So --rm command will automatically remove the container upon its exit. And we are going to choose also kernel memory. So we will allocate 50 megabyte of kernel memory, and also memory reservation is going to be 800 megabyte. So you can also set working directory. You can do a lot of steps here, but I have shown you some of the options that I could think about while recording the video. So you can try out a lot of different things based on your need. And if you click on here, you can see the equivalent command. And in the build option, you are also allowed to pass in parameters or pass in some options. So in this case, you can say memory. So when you build this image, that should not exceed more than 500 megabytes of memory. You could also say remove cache. You can do a lot of things. When you type in --r, then it will show you all the possible options that has kind of like R in it. So click on run. This should actually start building the Docker image. In the build log, you can see that information. And on the under the image section, you would see Java Spring Boot latest, right? So this has already built the image, and we can see a warning. So that's fine. Warning is fine. It's not a problem at all. And in the log, you can see actual application log. And as we actually enabled build kit, so that's why you see the summary of build time for each layer in the image, right? So in the properties, you can see the metadata that we have seen multiple times, and you can see the container name, image ID, right? And in the env variables, you can see all the assigned variables, right? If you want to add more, you can do that as well. If you want to remove, you can do that, but remember to save it, because if you do not save it, it's not going to be applied to the container. In the port bindings, you can see we have exposed to this time 8080 port on the container part, and on the host port we have also done 8080 exposed, right? So if you want to modify them after you have fired up the container, you can do that as well. And volume binding is for data persistency, right? So if container dies later on, you want to keep the data still in the file system, so that if you fire up another container, you can hook up or you can attach your volume to that particular container, and you can get the data available there, right? In the file section, you can access the files when a container runs, right? So let's start the container, and we should be able to see the logs. And if we click on files, we should be able to access the file systems within the container, right? So here you can see all the files within the container, and if you right click, you can go to show logs, you can go to copy image, inspect, you can see processes. So in our case, we have Java and Java version, right? So we run the application and we run the Java version command, right? So in the edit configuration, you can go back and you can still modify, and you can delete some or you can update some configuration from here as well, in the build image, or in the build part, or in the run configuration settings, right? So if we right click any of the images, we can fetch information, or we can push images also to a container registry. If we right click on a container, we can get more information. For example, in this case, we can look for host name, because we had a customized host name for this container, and we should be able to see the host name which is assigned to web app, right? So this is how you can kind of like find information, inspection menu, and you can also do some stuff with exec and create terminal. I'm going to show you this part more thoroughly. So in the exec, so what you could do, you could write something within the container, or you can fetch some information. So let's create a terminal within the container. So I'm going to run a couple of commands, uname -a, so getting some platform information, right? And as you can see, we are running Oracle Linux 8.4. Our Docker image is actually built on Oracle Linux. So we want to also fetch the host information, so we can do so as well. So what we are doing right now within the container terminal, we could also do the same thing using exec command, right? As you have seen, I was fetching information ls-ls/opt, which was giving me the information, right? Right click on the container and choose exec. So once you choose exec, you can create and run, or you can manage. So in the manage section, you can add or delete commands that you have previously run, right? So I'm gonna kind of like clean them up, and I'm gonna run ls-ls/opt. So now we want to execute the command, so we need to go back and select exec, and this time if we click, it's gonna output the information. So the similar thing actually we could do from the terminal as well. So we have a running container, so docker ps will output the running containers. So we're gonna run docker exec id, and then the container id, and then the command, right, that we want to perform within the container. So this is the same thing, exactly same thing that we were doing before from the Docker CLI. So now you do not have to do it anymore. You can just do it from the UI. Isn't it cool? So let's have a look on the left hand side menus, the options. So if you wanna edit something, you can edit them. If you wanna stop, if you wanna delete, all the options are available there. You just need to explore a bit more and play with that. So if you want to recreate a container, you can do that as well. So when you recreate a container, it's going to use the same configuration that you have defined. It's not gonna put anything out of the blue, right? So this is really good. So when you run docker ps, you can see the container is running. So this time it's gonna have a different container ID. So if you wanna see the logs, so we can run docker logs and the container ID. The same thing we were actually doing from the UI. So we are really happy because our container is running. So it's time to push our image and share with everyone. So in the repository, you need to pass in the repository, and in the tag section, you need to pass in a tag name, right? So once you do so, click OK, and you should see it has started pushing images to the container registry. So in my case, I have defined Docker Hub, so it's going to push the image to Docker Hub. It's excellent. The image has already pushed. You can see the log here as well. So let's go and verify in Docker Hub. So open up a browser and type in hub.dockerhub.com, So I have already opened it. So you can see the first one is the one I just pushed just a while ago. So if you click on tags, it's gonna show how many tags available for this particular image. And if you click on the particular tag, then you can get more information about each layers. So I'm gonna show you the same thing within the terminal. So first of all, we need to get the image ID. So we fetch the image ID from here by running Docker images, and you can type in first 2 or 3 char. It has to be unique, right? So or you can just copy the entire the image ID and you run the command. So that will give you the history of the image, what has happened in each layer, right? So I hope you get the idea how to use Docker in IntelliJ, and in the next video I will be talking about Docker Compose in IntelliJ. And if you like the video, if you want to support me, like, share, comment, and see you in the next one.